Hi, I'm Phil Zimmerman, and I'm here to talk about my Secure VoIP project. I've talked at DEF CON before about it, but I thought I'd bring in an update. This was a kind of a substitute talk for a time slot that opened up, so this is not well prepared in advance, but perhaps I can just show you what I've been up to lately, especially since last year. The project is it's called ZFONE, and what I have is three things. I have a protocol specification that describes how to negotiate cryptographic keys for an encrypted voice over IP call. There's also a software development kit that implements the protocol that can be used in the creation of other VoIP products, so that if you are making a VoIP phone and you want to put my SDK into your VoIP firmware, or if you're making a soft VoIP client, you can put it in that, or you can put it in a PBX. We have it running on Asterisk. I'm going to be demonstrating that today. Then your VoIP product becomes capable of running my protocol. The protocol is called ZRTP, and the third thing that we have is an application called ZFONE that makes use of this protocol. ZFONE is not a VoIP client, but rather is an IP filter that runs in your IP stack that filters the VoIP traffic as it goes in and out of your computer. So it's sort of like a bump in the wire, except there's no wire, so it's like a bump in the IP stack. So you can run any VoIP client you'd like to run, and except for Skype, and Skype doesn't tell you what their protocol is, or they're pretty secretive about it. So if you're running one of the other VoIP clients, like I like to run Apple iChat or Gizmo or a couple of other ones that I like to run, and I'll be showing three of them here. So I'm going to take down this web page. This is the ZFONE project website. Our sort of thing that we like to say is that ZFONE lets you whisper in someone's ear from 1,000 miles away, and that's the kind of sort of breakthrough experience that this brings you. We're going to get rid of that there, and first thing I'm going to do is run Apple iChat. Now this is the ZFONE GUI. It's put there by the daemon that's sitting in there running the IP filter. It's going to watch for a VoIP call, like the iChat VoIP client is going to do a connection. ZFONE will intervene and do a key exchange at the beginning using Diffie-Hellman, and then it will start encrypting it. I hope we've got some sound coming out of the laptop. Ah, there we go. Whoa, it's kind of loud.
Ron, hello there.
Hi, Steve. Don't talk too loud. I got it loud. It really turned up here. Turn the gain down a bit here.
Testing 1, 2, 3.
This is my friend Steve, who
howdy.
We demoed with last year.
Howdy.
Okay, so Steve, it looks like we've made a secure connection,
Right.
and we've got secure audio and secure video. And just to make sure there's no man-in-the-middle attack, let's see if we're using the same cryptographic keys on both sides. So the short authentication string is Puppy Atmosphere. Is that what you have?
Puppy Atmosphere, yes.
Yeah, so your GUI is saying the same thing as mine. These words are derived from the cryptographic key negotiation that both sides have done. If they match, it means there's no man-in-the-middle attack. So it would be quite a surprise if there was a man-in-the-middle attack, although considering how many kinds of attacks there have been at DEF CON, I wouldn't be totally surprised by that. Okay, so I'm going to press clear, so we're going to go to clear mode. Okay. So Steve is now not encrypted. Okay, can you hear me, Steve?
I can hear you fine. I'm just protecting my identity.
Yeah, that's right. We certainly wouldn't want anyone to intercept this and figure out who you are. Okay, Steve, well, either you or I could go back to secure mode again by pressing this button. You want to do it, or should I? I guess I'll do it. I'll do it. Okay. Uh-oh. Now you've told me to go clear. Okay.
Sorry,
Oh, you thought yeah, okay.
I pressed the button too. So.
Yeah, you did. Okay. Well, all right, so go back to
Should I have
secure.
sunglasses?
Okay, we're secure again. All right, so next time we'll just have to make sure we understand who's going to press the button, so we
That's right.
have a little bit of what is it? What is that called? That's a race condition. Okay.
Race condition.
All right. So now we're gonna switch off the video chat with iChat, and we're gonna switch over to Gizmo.
Okay.
And now, remember I told you that ZFONE works with just about any VoIP client. Here's another one here called Gizmo, a popular VoIP client that runs on a lot of platforms. And there we are. Can you hear me, Steve?
I can hear you fine.
Okay, and again we're secure.
Yes, we are.
Zulu opulent. You know, this list of words is the same list of words used by PGP when you compare PGP fingerprints. How many people here have used PGP? Yeah? I can see that this is a completely random audience, this is a completely random sample of the general population, right? I wish the ratio were that high in the general population. So you know that a PGP fingerprint uses a list of words, and that same list is what we use here. In fact, we actually developed that list in 1995 for PGP phone, which was kind of a predecessor to this. That's when I first did a secure VoIP application, but at that time the internet wasn't ready. There was no broadband anywhere, really, and also there were no VoIP standards, so it wasn't the right time. But now it is the right time, and so here we are with ZFONE. Okay, so we're going to hang up this, and we're going to switch now to using ZFONE, and we're going to go through a PBX this time. Okay, now this is another VoIP client called ZFONE, which actually isn't supported anymore, unfortunately. But ZFONE I've configured to talk to my asterisk PBX at home. And my PBX at home, I have integrated the ZRTP protocol into the PBX. So what I'm going to do here is I'm going to call Steve, and we're both going to be connected through this PBX. And the PBX is actually going to act as a man in the middle in this case. But we have the protocol arranged so that it can handle that. Let's see. Okay.
Howdy. So working again.
Yes. Now I'm going to show you what happens when a wiretapper listens to this call. Okay. This is what ciphertext sounds like to the wiretapper. Oh, I see you're turning down the gain? Okay. So it sounds like white noise. That's real ciphertext. We're actually taking the ciphertext as it comes in and just sending it through the codec, and you're just listening to what the ciphertext would really sound like from a wiretapper's perspective. So I'll do that again. Okay. Steve, say something.
Yes, I had to push my speaker down a little bit so I didn't get blasted.
Yeah. So we can hear you, and that's, but the wiretapper would hear white noise. All right, so we're going to hang this up, and
Right.
I think that's all for the demo. Oh, wait, you know what I'm going to do is I'm going to call, I need a volunteer from the audience that has a mobile phone in their pocket that I can call a mobile phone. Now here, you see, a PBX you can use VoIP to talk through a PBX to call a normal telephone, and that's what we're going to do right now. So suppose I'm traveling in Europe. Suppose I'm in Moscow in a hotel room, and I want to call somebody here, right, on your regular phone, maybe a cell phone. And I don't want Vladimir Putin to listen to the call. So I want to make it encrypted from the Moscow hotel room to my PBX in California. And there it goes through a PSTN gateway to a local telephone. So could I get a volunteer who's willing to give me your phone number to dial in so that I can't mask the number. Well, wait a minute. Maybe I can. I'll just put this on top of it. No, I got to type it.
Just unplug the video for a second.
Unplug the video. For some reason, people are reluctant to give out their phone numbers into this audience. What is it about this audience? Okay, this has to be a real mobile phone in the room, okay? Okay. Yeah? 415, what? 200 656. Oh. 200 7656. Okay. So I'm going to dial that. It's making a connection to the PBX and is dialing out through the PSTN to your phone. Your phone is turned on, right? All right. Turn up the gain so we can hear. Oh, well, answer it.
Hello. Can you hear me?
Yeah, we can hear you.
Yeah, I can hear you.
Okay. So, hey, again, we'll do the same trick again. This is what Vladimir Putin would hear from if he's intercepting the call. See? Okay, but you can hear me fine, right?
You can still hear me.
All right. So now, but what if we want to check for the man-in-the-middle attack? You see, I want to see if this is these words here match right here. It says. Billboard retraction. Dial 77 on your phone.
Okay.
And listen. Is there a robot talking to you? What? What happened? No, not 977. 77, yeah. All right, never mind. It's too complicated. The point is... Actually, every connection that we make to the PBX from this VoIP client is going to already be authenticated because we've done it before. Because we use something similar to what SSH does. We use key continuity. You know that how many people here have used SSH? Gosh, almost the same number. It's almost as if you all had experience with security issues, right? Again, a normal, randomly selected audience. Well, you know that when you use SSH, the first time you make a connection, it caches some key material so that the next time you make a connection, if there can't be a man-in-the-middle attack, because if there wasn't a man-in-the-middle attack in the first connection, there isn't going to be one in the second connection. And I'm using the same thing. What happened here? Oh, are we still on? I should hang up. There we go. Yeah. We were connected all that time through your mobile phone? Okay. That means you could hear my talk through your mobile phone, right? Okay. Yeah. All right. So, here, let's just get rid of that so that no one could write it down, right? I guess his phone number must be in the buffer for this VoIP client here, but I don't think I'm going to be calling it anymore, so don't worry. Oh, he has my phone? Well, actually, no, because my PSTN gateway at home has the caller ID blocked, so he can't see it. That's because I got my phone years ago back. I'm sort of a Luddite about that. I have my caller ID blocked for my outgoing calls, which means that I can't call a lot of people because they block incoming calls that have the caller ID blocked. So, oh well. All right, so where was I? Oh, yeah. So I cache some key material in the first call and then keep it around for subsequent calls. So every call, it does a fresh Diffie-Hellman calculation. But it hashes the session key and stores that in a cache. So the next time there's a call to the same person, it does a new Diffie-Hellman calculation, but it detects whether there was still some cached key material from the earlier call, and mixes it in by hashing it together with the new key. So that if there was no man-in-the-middle attack in the first call, there won't be one in the second or the third or any of the later ones. It does this every time. Now, this is an interesting security property because it means that you don't really have to compare the short authentication string. Now, I did compare it because I wanted to show how it works, but you don't really have to compare the short authentication string. You could just rely on the key continuity properties that work pretty much the way SSH works, except instead of a signature key, you're not caching a signature key, you're caching a hash of the session key. And this means that you could call someone 100 times and never check the short authentication string. Call them 100 times, spread out over perhaps a year, and talk about harmless things, talk about the weather, talk about nothing important. But after a year of talking about nothing important, one day you want to talk about secret stuff. So you decide today we're going to compare the short authentication string. So you compare it and it matches, which means there's no man in the middle. But it also means retroactively that there never was a man in the middle in all the previous 100 phone calls that went back for the past year. Now that's a really nice security property. So you can be lazy most of the time, and all you got to do is check the authentication string just once. It could be at the beginning or it could be later on, and it retroactively it covers it in the past and going forward. It doesn't actually prevent the attacks in the past. It just lets you know that there weren't any. Of course, the corollary of that is that if it doesn't match after 100 calls, then that means there is a man in the middle in this call, and it also means there always was a man in the middle for all 100 calls, so it's a real oh shit moment. So maybe you ought to do it earlier than 100 calls. So this protocol doesn't rely on a public key infrastructure. It doesn't rely on servers. It does the entire protocol in the media layer, not in the signaling, the SIP signaling. It doesn't rely on the SIP signaling. It doesn't involve the phone company at all. In fact, if the media goes through a different path than the signaling, which it typically does, then the phone company doesn't even have to know you're using the protocol. There's nothing in the SIP packets that tell them you're using this protocol. So it's just between you and the other person. You and the other person are the only two parties that are involved in the negotiation of the cryptographic keys that will be used to encrypt the media. Remember in the old days, there used to be these devices you could buy for a couple $1,000 that you would plug your phone into, and they would do a modem connection and negotiate keys that way. There was one in the early 90s that had a clipper chip in it, and you know, that was also something that didn't involve the phone company. However, it had a clipper chip in it, so there was built-in wiretap-friendly stuff. This protocol doesn't have any wiretap-friendly stuff, and it doesn't involve anything. It doesn't involve the phone company in the key negotiation. Now, as many of you know, there have been some things that have happened that make us question whether the phone company has our best interest in mind. So I'd rather not ask their permission. If I want to speak Navajo to my friend on the phone, I don't want to have to get permission from the phone company to speak Navajo. And so I think that's the way encryption should work. There's another protocol that does involve a public key infrastructure, that does involve certificate authorities and sort of a top-down thing. It's called DTLS SRTP, and that's another way to do it. But if you do it that way, you're relying on a central authority, you're relying on a public key infrastructure. Now, I think that public key infrastructures can be made to work in some environments, like web servers and web browsers. You know, there you have one server talking to a lot of web browsers. But when you want to have a many-to-many architecture like email, during the 1990s, a lot of companies attempted to build public key infrastructures for email encryption and failed. And in fact, a lot of them went out of business. It's very difficult to do. It involves building a bureaucracy. You have to have somebody run the public key infrastructure, set it up, check people's credentials, and so on. It's hard to do. So that's why PGP succeeded where SMIME failed. And other predecessors to SMIME, like Privacy Enhanced Mail in 1991, MOS in the mid-90s, and later SMIME. And SMIME had a lot of deployment advantages because it was bundled with Microsoft software, and yet it never really got used a lot. And the reason why is because it required too much activation energy, because you had to create a public key infrastructure to use it. PGP didn't require building a centralized public key infrastructure, so it was more widely used. Well, I think that the things that made public key infrastructure difficult to do for email become even more important for phone calls. Phone calls are more ephemeral. There's no reason to keep around keys, because at the end of the call, you're done with the call. You don't need to decrypt it next week like you do with a piece of email. So why should you keep the keys around? So you don't need a public key infrastructure. So this is a more lightweight approach, and it can also be used in, like, for government agencies that want to use it. You know, if you're going to try to build a monolithic organization like a military organization, you can make a PKI work. But if you want to have an interagency thing, maybe first responders, you know, Hurricane Katrina, decentralized mesh networks, that sort of thing, you're going to have not everyone marching to the same drummer. You're not going to have everybody under the same command. And so to try to get them all to work with the same PKI is not easy to do. But with this approach, it'll always work. So I think it's a better architecture. So anyway, let's see. Yeah, okay, so we're done with that. All right. So anyway, visit the ZFONE project website. It's got a great FAQ page. You know, there's lots of Wikipedia links in here, and take a look at it. Download it. You can download it for free to try it out, and you can get the SDK and play with it in your product. And you can also download the Asterisk patch. So if you have an Asterisk PBX, you can play with that too. Yeah. Can you send encrypted audio over the PSTN? Well, you heard what encrypted audio sounds like. It sounds like white noise. No, you can't really do that. But what you could do is you could send it through a modem, you know, and send UDP through a modem. But I don't think that's the question you were asking. I think that for the PSTN, you would have to take a different approach. And, you know, a famous hockey player said, I always try to skate to where I think the puck will be. And I think the future of telephony is more likely to be in VoIP. So that's more interesting to me than encrypting the PSTN. Yeah. Louder, please. Before it gets into what? No, I encrypt the data after it's been compressed.
But do you address the recently discovered program that can drop the voice calls with variable bitrate without any?
Yeah. The question is, what about these variable bitrate codecs that leak information about the speech? Well, I think it's a good idea to not use variable bitrate encoders for secure telephones. I think if you're building a secure telephone, it's better to use constant bitrate codecs.
Yeah, but we don't enforce in any way like what the people can choose for their program, so you don't disable.
Well, you know, you can configure your VoIP client to just exclude the variable bitrate codecs. There's only a couple of them, and most of them are constant bitrate. So, you know, use GSM. You know, use.
Yes, I understand, but what I meant that many people can be unaware about this program, and if you somehow tell people in the manual or somehow like
Sure.
switch it off in your program.
Well, I'm probably going to add something to my FAQ page about that. If I didn't already. Maybe I did. I wonder if I did. Huh. Well, I know I was thinking of adding something. Okay. Let's see. What else? Yeah.
Conference calling?
With conference calling, how do you encrypt conference calls? Well, you remember the way conference calls work is that everybody calls a conference mixer. In fact, a lot of times a conference mixer is a PBX. So you would encrypt each link to the conference mixer, and the audio mixing is done at the mixer. So you're doing individual encrypted links, and they're all ZRTP connections. So it's not like you have to work out the keys between every party. You just link. You're just doing key negotiation only between each party and the mixer.
So the primary client's acting as that mixer. Is that correct?
Yeah, we have done conference calls with the ZFONE.
And it just reads back the automated voice to you?
Well,
Detect the words?
what we've done is we've done a protocol extension to have a shared secret between your VoIP phone and the PBX. And so once that shared secret is established, it's there all the time, and so it's pre-authenticated. Yeah.
So just about what you just said, the conference call, does it come into the PBX and then has to go back to audio and then it goes back to encrypted out?
Yeah. The PBX, let's assume that the PBX is acting as a conference bridge, and it's a conference mixer. It's doing mixing of the audio, and so it has to have the plain text there. I mean, that's just what audio mixing. If you're gonna do audio mixing, you need the plain text. There's no way to avoid that. You're going to have to trust the conference mixer. Typically, you own the conference mixer, so it's yours. Yeah. Yeah, it's a patch to the source code. You can download the patch, you rebuild Asterisk, and we actually have a patch for like 3 different versions of Asterisk. You have to recompile Asterisk. Now, later on, we could put it into the Asterisk code base, but I think Digium's going to have to agree to that, and I think at some point they will, but that hasn't quite been worked out yet. Yeah. Well, I think a number of people that build these Asterisk systems could put it in, and then ship the systems with that already put in. Yeah. Say that again. Well, BlackBerry software. The question is, can we put this on a BlackBerry? BlackBerry is not a very open architecture, and to the extent that they let you do anything, you have to write it in Java. So I think it would require a special relationship with BlackBerry, with RIM, to make something that's written in C for them to insert it on their product. Now, that would be kind of up to them. What? Windows Mobile does have a VoIP client that has this integrated. There's 3 companies in Europe that are working on VoIP clients that use this on mobile phones. There's a company in Latvia called Tivi that has a VoIP client that they've integrated this into. There's another company in Italy that's working on a VoIP client for mobile phones that will have this integrated in. And there's a company in France called Atelier that has, they're not doing a VoIP client, they're doing something actually quite unusual. Instead of taking our SDK and putting it in a VoIP client like we usually do, they're taking ZFONE, the ZFONE application that I just showed you, and they're porting that to Symbian, and then you're running the Nokia VoIP client, or maybe other VoIP clients, and having it intercept the packets the way ZFONE does. And I've seen that work. I was just in Paris a few weeks ago and saw it work, and it works pretty good. So there's different ways of getting this on a mobile phone. And in Europe, it's more popular in Europe than it is here. And mobile phones are more popular there too, I guess. You will be able to get this for your mobile phone. And also, I know of someone working on an iPhone implementation. So I just bought an iPhone. I just got my iPhone yesterday, so I'm looking forward to that. I want to be the first user. Pardon me? I would. Yeah, I'm going to push for the iPhone version as soon as possible because I use an iPhone now and I want it now. Yeah. Louder, please. Yeah, I know. Apple. The question is, will Apple distribute the VoIP client with ZRTP embedded in it? Well, I don't know exactly, but I know that they do have a way of accepting applications to put on their online store, and we certainly will be trying to arrange for that to happen. Well, actually, there is a VoIP application for the iPhone. What's it called? Fring or something like that? Yeah, there's a couple of. I think there's a couple of VoIP clients for the iPhone. So one more is not going to be a big departure from what they already have. I think they're running it over Wi-Fi and not the 3G network. I think that any efforts by Apple to stop it is probably going to be focused on stopping it on the 3G network. But they're going to allow it for the Wi-Fi. At least they do for the other one or two VoIP clients that you can download right now for the iPhone. So I think there's a good chance they'll allow this. And if they don't, well then there's always other ways to make it available. In fact, maybe I'll ask some of you guys to help with that. Yeah. Are any government agencies using ZFONE? Well, government agencies have used PGP quite a bit. There's, thousands of seats of PGP in government agencies for many governments around the world. I imagine that at some point they'll be using either ZFONE or they'll be using phones that have my SDK embedded in them. But do they use it now? No, they don't use it now. At least not that I'm aware of. Although maybe some unofficial use. Yeah. Say that again?
Just at least in a general sense. I'm not asking for like dial plan and code example, but how would a connection between two asterisk boxes that were appropriately matched?
Connections between asterisk boxes, I think most often use another protocol called IAX, and this doesn't work with that protocol because IAX is a protocol that mixes many calls together in the same connection. This is a protocol that's designed between two people, a single connection. Yeah, if you can get a SIP RTP connection between two PBXs, then this will work with that. Now, for those of you who want to download the asterisk patch and try it, I'm going to give you the URL for that here. You can get it here. I don't know if it's visible on the screen, but you can copy that down. See, we've got patches for 3 different versions of asterisk. Or just send me an email, and I'll make sure you get the latest one, and then you can try it out. I'd like you to try it out and tell me how it works for you. In fact, if you want to look at the online documentation, just go to that asterisk page and look here. We've got a user's guide, and it'll show you how we set it up and how to configure it on your asterisk box. So, anyway. Yeah.
More of a general question, if you don't mind. But since you're in the field, have you seen, with VoIP becoming the next telephone system, basically, have you seen instances where government agencies are starting to kind of push on the telephone restrictions onto VoIP?
Well, do you think that they will oppose encryption for VoIP? Is that what you're asking?
Or possibly require some kind of a backdoor for law enforcement?
Well, let me take the first question first, which is, will they oppose encryption for VoIP? And I think that they're going to have to accept encryption for VoIP, and not just in a few cases, but they're going to have it everywhere. The reason why is because while there's a large asymmetry in the difficulty of wiretapping between governments and everyone else. The government can easily wiretap the PSTN, but everyone else has to, they have to go to the phone company and ask for a wiretap, and the phone company is not going to give it to you, but they will if you're the government. Now, that's true for the U.S. and a lot of the Western democracies. It's not always true in every country. In some countries, there are corrupt governments, corrupt phone companies. You can bribe someone and get a wiretap. I understand that in Brazil you can get a wiretap. You can get recordings of your business competitors' phone calls for a whole month for about $5,000. So that's like a published rate, you know. So, but here in the U.S., you pretty much have to be the government to get easy wiretaps. But that asymmetry in the difficulty of wiretapping will collapse as we move to VoIP, because with VoIP, it becomes equally easy for anyone to wiretap. And when I say anyone, that means anyone. That means organized crime. That means organized crime can wiretap the cops. They'll be able to wiretap judges and prosecutors. And that means they'll be able to listen to details of ongoing criminal investigations, the names of witnesses, the names of informants, and listening to them calling their wives at home to talk about what time to pick up their kids at school. So, you know, even if the local criminals are too stupid to do that, they'll outsource it to the Russian mafia, and the Russians will do it from Russia without ever setting foot in the U.S. So, you know, you can be wiretapped from the other side of the world by people that never had to get a visa to come into your country. It's not like they got to get close with alligator clips and clip them on the copper wires outside your office. They could do it from afar. So we have no choice. We must encrypt VoIP. The law enforcement community needs it as much as we do. All of society needs it. All of society can't migrate to VoIP without it. So will they have a backdoor? Well, you know, I think if you try to put a backdoor in, somebody's going to figure out a way to exploit it. Somebody other than law enforcement. And it just makes it weaker. It'll be an attractive nuisance. Let's see, what else? We got any other questions here? I guess, Let's see, how much time do I have? Oh, I still got plenty of time. Well, let's see, what else can I talk about? Yeah. Say that again? With source code available, can they keep you from using encryption? You know, I think that we fought the battle in the 1990s to be able to use encryption, and I think we won that battle. So I don't think they're going to be able to turn back the clock on that. And I do publish the source code. You know, and I've done something else that's kind of a strange thing to do. I've done some things in the protocol that try to discourage people from putting backdoors in their products. I put in a protocol element that says that if you are disclosing the cryptographic keys out of band, I mean, there's nothing in the protocol that has any backdoors. There's nothing that's part of the ZRTP protocol that has, you know, like the Clipper chip, you know, the law enforcement access field. There's nothing in the protocol like that. But there's I can build my own products with no backdoor, but what about other people's products that implement the same standard? They could conceivably leak the key material out of band. You know, they could send it somewhere that's not part of this protocol. They could just send it somewhere else. You know, maybe through an encrypted tunnel to someone else. And so if they do that, I would like them to identify which products are wiretap friendly like that. Because remember, back in the 90s, the Clipper chip. How many people here know about the Clipper chip? Okay, not as many as have used PGP and used SSH. Well, the Clipper chip was a wiretap-friendly chip that encrypted voice. And during the 1990s, there was an effort by the government to require that this chip be put into phones that do voice over IP. And it didn't succeed in the market because nobody wanted to buy a chip that had a backdoor for the government. So, Adam Smith's unseen hand, the invisible hand of the market, does not favor wiretap-friendly chips or wiretap-friendly protocols. So I'd like to try to use that. I'd like to try to encourage people that are going to make wiretap-friendly implementations of my protocol to reveal that their products are wiretap-friendly. Well, that's not so easy to do. How do I do it? So what I did was I put in the protocol a requirement in the specification that you have to set a special flag in one of the packets that says this product is wiretap-friendly. This product is designed to leak key material out of band, or whatever method they want to use to leak key material. But how do I get them to do it? Well, I filed a patent application for certain aspects of this protocol. Now, I don't like patents, and anyone who knows me knows that I'm sort of a anti-software patent guy, you know. But I'm giving away a free patent license. You can just use it for free. If you implement this specification, you can use the patent for free. It's just some patent on certain aspects of the protocol. So I'm not charging money for using the patent, but I'm saying that you only get this patent license if you meet the specification, if you actually comply with the specification. And the specification says that if you make a product that's wiretap friendly, you have to set this special flag in this packet, which the other party would see on his phone and would know that your phone is a wiretap friendly phone. So what I'm doing is I'm combining the invisible hand of the market and standards, you know, and intellectual property law together to discourage backdoored products. So it's kind of a radical experiment. So as long as the patent, if I get the patent, I haven't gotten the patent yet, I've just applied for it. But if I get the patent, as long as that patent runs, which is about 20 years, then people that implement this protocol are probably not going to be putting backdoors in their products. When the patent expires, can't help you there, but So, any other questions? Well, maybe we're done. So go download ZFONE and try it out. By the way, if you can attack it and try to maybe do some fuzzing attacks or something like that and find some weaknesses, I'll give you credit on the website. Maybe if you find a real weakness that way, maybe a buffer overflow attack or something like that, I could even put you in the about box. So try to do that. All right, that's it. Thanks.